Oh God, that seems so painful. Anyways, I hesitated if I should have shown that video to you guys. I hope that you are all, I know you are a lot more smarter, a lot smarter than that. Um, here's our 2.1D. This is the last section in Unit 2.1. And in the first three sections, you learned the concept of set, what sets are, the nature of it. You've learned three different ways to write and express sets. And in this last part, now that we know what they are and see how we can classify them, we're going to learn that that there will be finite and infinite sets. We're going to know how to determine empty sets. We're going to find the cardinality of a set. The cardinality is just the number of number of elements in each set. And then finally, we're going to learn to decide if two sets are equal or equivalent. Okay, without further ado, let's look at this example. How do we classify sets are finite or infinite? Very easy. The easiest way sets are those with the three dots in the end. That's fine. That's infinite. Everything else you have to read carefully and think through. So let's look at the first one. The set of X, remember this is the set builder notation, the set of X, and this bar says such that. The set of X such that X belongs to N is natural numbers. N belongs to natural numbers, and X is less than 100. So this means this includes all the numbers. If I use list method, I would do 1, 2, 3, and then the last number in that set is 99. So that is a finite set because you have exactly these numbers in there. It doesn't go beyond 99. Okay? Number 2, set R is the set of letters used to make Roman numerals. And we know in Roman numerals, there are a limited number of letters that's used. I think they have C, they have D, I obviously, like in 4, they have L, they have M, they have V for 5, and they have X. The last element is X. So that is our set, and that's obviously a finite set as well. C, we already said it's an infinite set. D, set M is the set of people in your immediate family. I don't know about you, but I have a huge immediate family with 4 children, so my set is pretty big, but regardless, thank God I only have a limited number of children because they can be so costly. So that's obviously a finite set, okay? Then last one, set S is the set of songs that can be written. You guys all know that you can write infinite number of songs. So that's an infinite set. Very straightforward. Give it a try on your own. Pause the video. And when you finish this, move on to the next example. Next concept is empty set. Empty set is a little tricky. So here's an example. The set of female presidents, of the United States. And I hope Hillary will get elected so that this will not be an empty set. Right now, there's no female presidents in America's history up till today. So hopefully that glass ceiling will be broken. Ironically, some countries that are considered far less liberal, a lot more behind than America, already have female leaders. Argentina is one, obviously. South Korea has a female president. Thailand has a female president. So those are just a couple of countries that I know of, not to mention some of the more historical figures. So it's interesting that as one of the superpowers in the world, we don't yet have the same representation between men and women. Anyways, so I digress. So when you have a set, this set here is all the presidents of America. But when you limit that to female presidents, because there is no female president, that set is empty. And so we say a set with no element is called an empty set, or a null, N-U-L-L, a null set. The symbol used to represent the set is either just two braces with nothing in it, or a zero with a cross with a line crossed over. Okay, remember, two different ways: empty braces and then zero with a line going across it. That's important. We're going to return to this concept later. Let's look at an example. Which of the following sets are empty? The set of woolly mammoth fossils in museums. Somewhere there has to have a mammoth fossil in a museum. So this set is not empty. Not empty. Okay. Next one, the set of elements X, such that X is a living woolly mammoth. And can we find a living one? I think they disappeared, right? They have been extinct for almost 8,000 years. So this is definitely an empty set. Or we can write this too. And C, we already said just braces with nothing in it, that's an empty set. Either way, either a zero with a line crossed over, or the braces will do the justice. Last one, the elements of X such that, remember, the bar says such that, the elements of X such that, the set of the elements X such that X is a natural number between 1 and 2. We said natural numbers are baby numbers, 1, 2, 3, 4, 5, 6, 7. Is there a number between 1 and 2 that we consider natural? No. So the last one is an empty set. Try this one on your own. Pause the video. Again, I want to point out, do not write the empty set as braces with zero, a line cross in the middle. This is not an empty set. This means it's a set within a set. So I've got a set here with the braces. Within that set, I have a null set, or I have an empty set. So in other words, this set on the left here is actually not empty because it has a null set inside. It has something inside. It has an element inside. And that element happens to be an empty set, but the total set is not empty. So be very careful with that distinction. I know this, I can guarantee you this will show up in your quizzes. Let's move on. Number 10, find the cardinality of a set. Let's look at the bottom here first. So the definition of cardinality is that it's the cardinal number of a finite set. Is the number of elements in the set. That's what it is. So it's an easy concept. So for a set A, the symbol for the cardinality is N of A, and that's read as N of A. So let's look at example A. I have 5, 10, 15, 20, 25, 30. I have 6 numbers in that set, so I can simply write N of A equals 6 because I've got 6 elements in there, and my cardinality is 6. And for B is 10, 12, 14, all the way to 30. It looks like those are even natural numbers between 9 and 31. So altogether I should have 11 numbers in there if you count it right. So I have 11 elements. My N of A should be 11. Okay. C, set C only have 1 element. So my N of C equals 1. Oh, I'm sorry, I made a mistake here. This should be B rather than A. Sorry about that. And then the last one is an empty set. Because it's an empty set, I say the cardinality of this empty set is 0. That's how I express it. Again, I want to bring your attention to what we just talked about. If I have a null set within a set, in this case, let me name this Q, set Q. So at my n of Q, in this case, should be 1, because inside those braces, I have a null set, and that null set is my one element in that set. You see the difference between these two here? Let me use a different color. Between these two, n of the cardinality of a null set is 0, and the cardinality of the set Q in set Q happens to have a null set in it, and that's 1. Okay, so pause the video, give this a try. This should be very straightforward. Now, one of the last concepts in this unit is the equal and equivalent sets, and they are not to be confused. Again, it's very straightforward. It says two sets, A and B, are equal. I gave it away with that equal sign there. So A and B, set A and B are equal if they have exactly the same member or elements. Apologies for the chicken scratch. It's not easy to write with the stylus on my iPad. So again, two sets are equal if they have exactly the same member or elements. Two finite sets. Oops, I don't need it. So two finite sets, A and B, are said to be equivalent. Equivalent. And it's written with a congruent sign, right? Congruency meaning equivalent. If they have the same number of elements, not exactly same members, but same number of elements. So in other words, their cardinalities are the same. The sets inside, the elements don't have to be the same, but their cardinalities, the counting of the elements inside the sets, have to be the same. So for example, the two sets ABC, that's one set, and CBA are exactly the same, and therefore they're equal, right? They have the same members, A, B, C, 3. Doesn't matter what the order is. 4, 5, 6 are exactly the same as 4, 4, 5, 6, or 4, 4, 5, 5, 5, 6, 6, 6, because earlier on in 2.b we mentioned that in elements can be repeated. It does not really matter how many times you repeat it. Most often we try to be lazy, do as little as possible. We only write, we ignore the repetition. We only write it once. Now set C, X, Y, Z is equivalent to 10, 20, 30. Why? Because their cardinality, the number of elements in each set, are the same. The cardinality of C equals the cardinality of D, and of D, which is 3. Okay, so this is about number of elements at the bottom here. And the red examples, they have to be exactly the same. Repetition is okay, but the elements have to be exactly the same. So here's an example. A, P, Q, R, S, and A, B, C, D. Obviously 4 letters in each set, so cardinalities are the same, excuse me. But the elements are different, so this one is equivalent, right? Okay. B, 8, 10, 12, even numbers between 8 and 12, 12, 8, 10. They're exactly the same and so this is equal. 213, hold on a second, is it 213? And the first one is 213, and the second set is 213. So 213 is just one number, and 213 has 3 elements, so they're neither. And D, 1 to 10, 20 to 120, 11. They're very, very similar with one difference, right? So they have the same number of elements. Their cardinalities are the same, but they both have 1, they both have 2, they both have 20. However, one have 10, one have 11. That is not equal. That is equivalent. And last one, even natural numbers less than 10. So let's think about it. Natural numbers, again, are baby numbers, 1, 2, 3, 4. If it's even, it's 2, 4, 6, 8. Less than did not say less than or equal to, so 10 is not included. Okay, so this one is equal. Also notice that if you're equal, you have to be equivalent, right? Because equivalent only means that they have the same numbers, and equal means they have to have the same numbers and they have to be exactly the same. So just want to point that out. Again, pause your video and try these. Finally, one-to-one correspondence. 2 sets have a one-to-one correspondence of elements if each element in the first set can be paired with exactly the same element. Can be paired exactly with exactly one element of the second set. Excuse me. And each element of the second set can be paired with exactly one element of the first set, one-to-one. It's very much like 2 sets of basketball teams on the court, and when they have a one-to-one correspondence, you see in this picture, you see the I can't tell which, I think it's Chicago Bulls in the white uniform, and the blue one is Indiana, in that they're one-to-one, right? So one element in one set has exactly one corresponding element in the others. So let's look at this example. Show that the sets 8, 6, 24, 32, and STUV have a one-to-one correspondence. So what you do is you write the first set on top. That's the first set. Then you write the second set, STUV, at the bottom. And then all you need to do is to show that they are having the same number of elements. Their cardinalities are the same. That's it. And the sets X, Y, Z and 5, 10 obviously do not have a corresponding. It does not do not have a one-to-one correspondence. So see if we line them up, X, Y, Z. Make sure the commas and the braces all line up. See, we have X and 5 as a pair, Y and 10 can be a pair, but what about here? There's nothing here. So this one is not one-to-one correspondence. Okay, so again, here's the final practice on your own. After that, please make sure that you finish today's independent practice as well. And as a final note, please review today's learning goal. Are you able to classify finite and infinite sets? And remember, infinite sets only applies to, so finite and infinite sets. Second, determine empty set, and we stressed several times that null sets does not equal the set of null sets. There are two different concepts. Are you able to find cardinality of a set, the number of units in a set? And are you able to decide the two sets are equal or equivalent? Equivalent meaning they have the same cardinality. Equal means they have to have same elements and same cardinality. Okay, so that's it for this session, and please be ready for your chapter test. Thank you, guys.